Today we're going to look at section 3.8, solving systems with matrices. Our objectives are to be able to solve a system of equations using matrices, specifically on our calculator, and to be able to set up a matrix equation. So how do you solve a system of linear equations with more than two variables? First of all, by hand, to understand why it's so important to use the calculator. But to solve it by hand, we're going to have to do a series of either substitution or eliminations, and usually we use a series of elimination. So I'm going to kind of go through that for you. So our goal is, because I have three unknowns, I need to have three equations. But I want to get down to two equations and two unknowns, so that way I can just use elimination or substitution like we're used to using. So if I look at equation 1 and 2, I'm going to label these 1, 2, and 3. If I take equation 1 and multiply it by a positive 2, I'm going to get negative 2x plus 4y plus 8z equals 20, where we have to multiply both sides. If I just keep this one the same, so by, in essence, multiplying it by a positive 1, I get 2x minus 3y minus 7z equals negative 13. So if I do this, I can eliminate my x's. So I'm going to get a positive 1y, a positive 1z, and again, this is 20 minus 13, which is a positive 7. So now I have one equation with two unknowns. Let's try that again. So let me look at equations 2 and 3. I'm going to take equation number 2 and multiply it by a negative 1. Okay? And that's going to give me a negative 2x, a positive 3y. This is equation 2, just so you know. A positive 7z equal to a positive 13. I'm just going to rewrite equation 3 exactly how I see it. So in essence, multiplying it by a positive 1. I'm going to get a positive 2x, negative 4y, negative 6z equal to negative 24. If I add these like we're used to for elimination, I'm going to eliminate my x's. This is going to give me a negative 1y, a positive 1z equal to a negative 11. So now I have two equations and two unknowns. So we can set this up like we're used to for just our normal elimination with two variables. So I know I have y plus z equals 7. Negative y plus z equals negative 11. So the nice thing is these actually eliminate right away, so I get 2z, and that won't always happen, equal to 7 minus 11 is negative 4, so z is equal to negative 2. Well, if I know z is equal to negative 2, I need to find x and y. Well, I can use any of my equations. I know negative y plus my z, which is a negative 2, equals negative 11. So I get negative y is equal to, if I subtract, or I'm sorry, add 2 to both sides, I'm going to get negative 9. So I get y equals 9. But I still have to find x. I can take any of my original equations that have x in it. Let me use the first one. Negative x plus 2 times my y plus 4 times my z should equal 10. So I'm going to get negative x. This is 18 minus 8, which is 10, equals 10. If I get negative x equals 0, if I subtract 10, so x equals 0. You don't want to leave your answer like this. Just like when we're solving a system of two equations and two unknowns, we write our answer as an ordered pair of x comma y. When we have three unknowns, x, y, z, we write it as an ordered triple. So x, comma y, comma z. Now that's kind of a lot of work. I had to do two elimination problems, then I had to do a third elimination problem, and then I had to solve for all my variables. Well, what we're going to do instead today is use matrices in our calculator to make this process a lot simpler. So how do we actually use the matrices? What we're going to do is convert the system of our last equations to what we call a matrix equation and then solve. What a matrix equation looks like is a matrix, I'm going to call it matrix A, times some matrix that's unknown. So it could be x and y we don't know, x, y, and z, and that's going to equal some other matrix, and we're going to call that B. Okay, so let's call this x just for us so we don't know it. Anytime I want to solve a matrix equation, we're going to use something called the inverse, and I'm going to show you that in the next slide what the inverse does. So the inverse of a matrix is something you multiply a matrix by, and you get what we call the identity matrix, which is basically one for matrices. So let's go back to what I just had. I had matrix A times some unknown matrix equals matrix B. there is no division for matrices. So normally if I have A times something equals B, I could divide both sides by A. We don't have that, but what we have instead is what we call the inverse. So I could multiply A by its inverse, and we'd use this notation, kind of like we did for transpose, but we're going to put a -1. A inverse times A is in essence 1, which is our what we call identity matrix. All an identity matrix is, it's a square matrix that has ones down the diagonal. So if this is a 2 by 2, it would look like that. If it was a 3 by 3, we'd have one down the diagonal, and all the rest would be zeros. Okay, that's what we're left with. Anything times the identity matrix, so our unknown, gives us back our unknown. So it's in essence like multiplying by 1. But the key is that you have to put the inverse on the left-hand side. So whatever I do to one side, I have to do to the other side. So this side now becomes A inverse times B. And that's how we're going to solve each of these problems in our calculator to find our unknown. So let's go back to the first example we just did. What we want to do is take our graphing calculator, okay, we're going to turn it on, and we're going to have to convert this to our matrix equation. So the first way we do that is we want to make sure all the x's, y's, z's, equal signs, and numbers are lined up. So then what I do is I look at all the lead coefficients for each of my variables. Okay, so I'm going to look at all the numbers. That's going to become my A matrix. So in front of x is -1, then I have a 2 in front of y, a 4 in front of z. 2 in front of x, -3 in front of y, -7 in front of z, 2 in front of x, -4 in front of y, -6 in front of z. And this, I'm just going to type in my A matrix in my calculator. Now, what have I forgot about? Well, I forgot about my unknowns. Well, remember, this is a 3 by 3. And the only way you can multiply two matrices together is if the middle, the column, the first, and the row, the second, are matched up. So I know this has got to be a 3 by something. Well, I have 3 unknowns. So I can do x, because that came first, then my y's, then my z's. So this is actually going to be a 3 by 1. If I take a 3 by 3 and multiply it by a 3 by 1, you should remember that that gives me a solution of a 3 by 1. Well, where am I going to get this 3 by 1? Oh, whatever it's equal to. It's equal to 10, -13, -24. Okay. So from our previous lessons, you should know how to type these into your calculator. I'm going to type this into my matrix A and this into matrix B. I've already done that to save a little time. So just so you know, if you ever want to see what you have in a matrix, if I put A on my screen and I hit enter, you can actually see to make sure. Sometimes this is an easier way to see to make sure you didn't make any typos. So -1, 2, 4, 2, -3, -7, 2, -4, 6. Okay. So what I want to do is I want to actually solve this. So what I'm going to do, if I want to get this guy by itself, what I'm going to type into my calculator, x, y, z, is I need to move this matrix over. The only way you can move a matrix, since we don't have division, is to use its inverse. So I'm going to type into my calculator A inverse times B. The nice thing about this is if you always type this matrix into A in your calculator, always type this into B, solving for your unknown, you're going to type this into your home screen every single time. So it's kind of nice for the consistency. So I'm going to type A. Now to get this -1, we're actually going to hit the button that we use to get to matrix without hitting the second key. So I'm going to hit this x -1 button, and it puts a little -1. Times, and we're going to go back into matrix B. So this gives me 092. That's the exact same answer I was able to get when I did this by hand. So what that tells me is that x, y, z equals 0, 9, -2. But remember, this problem didn't start off as a matrix. It started off as a system. And that's why ultimately in the end, I want to actually write my answer as that ordered triple, 0, 9, -2. You will get marked off on a quiz or test if you leave your answer like this, because if I started off with matrices, that would be a perfectly acceptable answer, but I didn't, so we would answer this as an ordered triple. So let's look at another example. Okay, let's make sure the x's, y, z equals number. X, y, this one actually has no z's, equals number. X, y, z equals number. So it's already lined up. So what I'm going to do is take the lead numbers. So 5, 4, and there's a 1 in front of this z. have a 5 in front of x, a 2 in front of y. And if I have no z's, that means I put a 0. I have a 2, a 5, a 2. Again, my unknowns in order, I chose to do x, y, z, so this is going to be x, y, z. If you write these in a different order, like you say you put the z's, then the x's, and the y's, that's okay, but you'd have to do z, then x, then y. Equals, and it equals 14, 3, and 24. So take a second to type this into matrix A, and this in the matrix B. And again, to solve for our unknown, x, y, z, I'm going to have to move this matrix to the other side, which we use the inverse. So I'm going to do A inverse times matrix B to get my solution. After you have that typed in, it should be fairly simple. We're just going to go on our home screen and do matrix A inverse times matrix B. Okay, and I've already typed those in. So we get an answer of -1, 4, 3. So I know that x is -1, the y is 4, and the z is 3. But again, I know my answer should be written as an ordered triple, so I'm just going to write -1, 4, 3. Now, could you have made a typo and got a wrong answer? Absolutely. So what you should do before moving on is always just go back to each equation. Substitute in a -1 for x, a 4 for y, and a 3 for z. You should get back to this answer. If you don't, for all three equations, then you know you made a mistake somewhere. So there's no reason to not get these all correct. Let's go on to our next example. This happens to be a 2 by 2, two unknowns. Now you're used to doing this, and I'd probably do this one by substitution, but you can always use your calculator as long as I don't tell you to use the substitution method. So if this is on the final, just do it by calculator if you'd like. But if you notice, my x's, y's, equal signs, and numbers don't line up. It is on the bottom one, but the top one isn't in the correct order. So I'm going to rewrite that. I'm going to move the x's to the left, so I'm going to have a positive 3x. I already have a positive 1y, and it's going to equal 5. So now that it's like that, it's really easy to set up my matrix equation. So I'm going to do 5 for the x, 2 for the y, 3 for the x, 1 for the y. And I put the x's first, then the y's. This one is a 2 by 1 because we only have 2 unknowns. And again, this should only have 2 solutions. We have a 9 and a 5. No matter what, this is matrix A, this is matrix B. So to solve for x and y, again, to move this over to the other side, I'm going to do A inverse times my matrix B. Take a second, make sure you have those typed in. So now I'm going to go to my calculator. I typed this into A, this into B, so I'm just going to do matrix A inverse times matrix B. Okay. I'm going to hit enter, and I'm going to get 1, 2. So again, I started off with a system, so my solution is going to be 1 for x, 2 for y, and we can make sure that works. If I substitute a 2, 2 equals 5 minus 3 times 1? Yes. Does 5 plus 4 equal 9? Yes, so I can be assured that that's a true statement. All right, let's look at this word problem. So a pilot has 200 hours of flight time in a single engine planes and twin engine planes. Renting a single engine plane costs $60 per hour. A twin engine costs $240 per hour. The pilot spent $21,000 on rentals. How many hours did the pilot fly in each type of plane? So this is my question. So that helps me set up my variables. And again, that's what you always want to do first. How many hours did the pilot fly in each plane? Well, I'm going to use x and y just to make life easy. X is going to be how many? The number of hours in, let's do the single engine plane. Okay, and then I'm going to say y is the number of hours in the twin engine plane. Okay, putting these units is extremely important. Just don't say single engine, twin engine. Is it the cost? Is it the time? Is it the weight? This is the part that a lot of students forget and you lose points on it. So now that I have this, I can write my two equations. The first total I see is 200 hours. Well, hours comes from hours of the single engine plus hours of the twin engine. So it's just x plus y equals 200. And putting these units helps you understand it's x plus y. My second total is the money. 21,000. Well, how did I get that? It's $60 for every hour in the single plane plus $240 for every hour in the twin engine plane should equal 21,000. I have my x's, then my y's equals my numbers, so now I can go right to my matrix equation. 1x, 1y. 60 x's, 240 y's. And again, I have the x's first, then the y's. It's going to be equal to my two totals, 200 and 21,000. So take a second now. I'm going to substitute that into A and put this into matrix B. So once you have those typed in, again, I'm just going to show you the work of how we get the unknowns by itself. I'm going to move the matrix A over by using its inverse. And again, it is key that the inverse goes on the left-hand side. If you put it on the right-hand side, you will not get the correct answer. So I have these already typed into the calculator. Now the nice thing is every problem I've been typing in A inverse times B, A inverse times B. So I can save time. If that was the last thing you typed in, you can hit second enter and it'll pop back up on your screen. And if you have new A's and B's in the calculator, it's going to use the new ones you typed in, not the ones previously used. So I'm going to hit enter, and I get 150 and 50. So let's think about what that means. 150 was my x, so that means I had 150 hours in the single engine plane, and 50 was my y, so I have 50 hours in the twin engine plane. And that's how you want to write it, because it's a word problem, so you want to use words. So I spent 150 hours in the single engine plane, and 50 hours in the twin engine plane. And that's would be your final answer. We took a word problem, wrote out our system, used matrices to help us solve it quicker, and then wrote out our answer, our final answer. So why don't you try this one on your own? If I were you, I would pause the video now, kind of use your notes, see if you can type in this matrix equation that's already done for you. Now I'm solving for x, so sometimes if you look, this doesn't look like a matrix. This is just saying a matrix times, we know this has to be a matrix equals a matrix. They're just using x for an unknown, but you should know that we are actually solving for another matrix. So take a second to see if you can type this into A, this into matrix B, and solve for your unknown. Hopefully you noticed, and I'm going to reveal the answer now, that our answer isn't a 2 by 1 like we've been doing before, because a matrix that's a 2 by 2 equal to a 2 by 2, the only way we can get that solution is if our unknown is a 2 by 2. So hopefully you're able to get that. I'm going to go through one last problem. I just want to show you that once you get to the higher math and harder problems, you can still use matrices to solve for any type of unknowns. So if we look at this problem, we have x squared plus y squared plus ax plus by plus c equals 0. This is a crazy long equation. This is actually the standard equation of a circle. And we are actually going to deal with some of this kind of stuff second semester. But it said find the equation of the circle that passes through the points 3, -1, -2, 4, and 6, 8. And you might be thinking, I have no idea how to solve that. Well, they give me values, and if you remember, this is just x and y, x and y, and x and y. And they give me an equation. Well, there's a bunch of x's and y's in here. So even if you're stuck, you should think, well, if I know what x is and I know what y is, I can substitute it into my equation. So let me try that first. X is 3, so I get 3 squared, plus y is -1 squared, plus a times x, plus b times y, plus c equals 0. All right, so I can clean this up a little bit. Okay, this is going to be 9 plus 1 plus 3a minus 1b plus c equals 0. All right, but I have 3 unknowns. I don't know what a, b, and c are. Oh, well, if I have 3 unknowns, I must need 3 equations. Well, nice enough for them, they gave us 3 points. So let me do the next set of points. So -2 squared, if I substitute in for all the x's, and I'm going to substitute in 4 for all the y's, plus a times -2 plus b times 4 plus c equals 0. If I clean this up, I'm going to get 4 plus 16 minus 2a plus 4b plus c equals 0. And again, we need one more equation. So now I'm going to substitute in 6 for all my x's and 8 for all my y's. A times 6 plus b times 8 plus c equals 0. And again, this is going to be 36 plus 64 plus 6a. And again, we always like to put the number in front of our variable, plus 8b plus c equals 0. All I have here is 3 equations and 3 unknowns. But again, remember, we always want everything lined up. In this case, a's, then b's, then c's, then numbers. So if I take the first equation, I'm going to get 3a minus 1b plus c equals, and this is 10, so if I move it to the other side, negative 10. The second one's going to be negative 2a plus 4b plus c. And if I add 4 and 16, I get 20. Move it to the other side, it becomes negative 20. And the last one is 6a plus 8b plus c equals 36 and 64 is 100. And I move it over, I get negative 100. So if I take this and practice right now, you could pause the video, put this into a matrix equation and solve for a, b, and c. So I'm going to reveal the answer in a second. So if you want to see if you can get the correct answer on your own, pause the video now. Okay. And here is what we should get. We should get a, b, c to equal negative 6, negative 8, and 0. But this is the thing with this question. It didn't ask us to just find a, b, and c. It said find the equation of the circle. Well, here's our equation of our circle. So now to get our final answer, we want to actually substitute in what our a is. So this is minus 6x. What our b is, minus 8y. And then plus 0, which we don't have to write, equals 0. This would be our final answer. So you just took a problem you've never seen before, and just using the stuff we've done before, are able to solve it.